Good day, grade 11s. So in the previous video, I was showing you how to plot the linear function, right? So in this video, I'll be showing you how to plot a quadratic function, right? So if you haven't watched the previous video, I advise you to go back to the channel and watch the previous video and understand it. So in this case, we have the equation, the fundamental equation for the quadratic function, right, which is ax squared plus bx plus c, right? So in this case, let's say for example you are given y is equals to x squared plus 2x plus 3, right? So if you can check, I want you to check something here. So if you can check here, we have 1. So this one correlates with a, this 2 correlates with b, and this plus 3 correlates with c. So in this case, we have a as our 1, b is equals to 2, and c is equals to 3, right? So before doing anything, you have to capture these things so that you can be able to use them later here, so that you can be able to use them. And then secondly, we have to have our Cartesian plane, right? So you have to make your Cartesian plane, or maybe sometimes you can be given your Cartesian plane. You just have to plot your Cartesian plane. So in this case, let me draw my Cartesian plane and make it precise as possible. Make it as accurate as possible, yes. So, okay, in this case, let me just do this. Right. Okay, yes. So this is my Cartesian plane. Sorry, let me just see. So this is my Cartesian plane. Okay, cool. So let's move on. So when you remember, quadratic function has something we call a vertex, which is a turning point, right? So quadratic function is something like, it can be like this, it can be like this, it can be like this. So in this case, it has what we call a turning point. So most of the time, the turning point is located here. So before doing anything in this case, you have to calculate your turning point. So the question is, how do you calculate your turning point? So there is an equation for that, which is x is equals to negative b over 2a. So remember, so here, this equation is to help you to calculate the x coordinate of the turning point, right? So it's not hard to use this equation if you have identified this thing. So do you realize the importance of having this thing? So in this case, what you can do, you can just substitute. So you can say x is equals to a negative. What is your b? Your b is 2, and then 2. What is your a? 1. So in this case, you're gonna have x is your x is equals to negative 1. So in this case, you're gonna have your x coordinate, the x coordinate of your turning point is negative 1, right? Let's just do this. Cool. So we are sorted. So the next step, remember, you need coordinates to plot a function. You can't plot a function without coordinates, right? So in this case, we have to get our estimated x coordinates. So most of the time, you do the estimated x coordinates or on the table like this, right? So let's say I've already identified the coordinate of my turning point. So in this case, I can just demarcate this, and then before doing anything, remember, so negative 1, so after negative 1 we have 0 and 1, and before negative 1 we have what? We have negative 2 and negative 3. So we have to like identify these things. So these are your estimated x coordinates, right? So our next step is what? Our next step is finding the y coordinates. So how do you calculate your y coordinates? It's very easy. So if you have an expression like this, you see, like, this expression isn't like the x is in x form, right? So meaning in this original expression, original equation, you can just substitute this estimated x coordinates. So the first one is negative 3. You can just put your negative 3 here and square it plus negative 3. Okay, we have 2 here plus 3. So putting this into your calculator, just check what you get. So in this case, we have negative 3 squared plus 2, negative 3 plus 3. So in this case, you're going to get 6 as your answer, right? And then you're going to move to the next one. So next one is y is equals to negative 2 squared plus 2 negative 2 plus 3. So again, you put this. Okay, let me just write it properly, sorry. Again, you put this into your calculator, just to make sure that I gave you a right answer. And if I made a mistake, just comment and tell me where did I make a mistake. So in this case, when I have your 3, right? So 3. Okay, let me just make this a bit smaller so I can be able to keep writing. Cool. So the next one, which is our turning point. Remember, we got our x coordinate of our turning point using this equation. So now to get the y, you can just do the very same thing, substitute into this original equation. So you can just say negative 1 squared plus 2 negative 1 plus 3. So in this case, what do you get? Do your math. Negative 1 plus 3, and then we're gonna get something like 2, right? As we move on, so we're moving on to this one. So in this case, remember substituting 0 here, we're gonna get 3, right? So let's move on. So in this case, we have this one next. So y is equals to 1 squared plus 2 1 plus 3. So just put the whole thing to your calculator and tell me your answer. So your answer is gonna be 6, right? So you have 3, you have 6. So let's just make all this small so that now I can plot. Okay, sorry. In this case, I erased some of the things that we have done, but you saw all the steps. So let's do it. So now we have our coordinates. So now let's just calibrate our Cartesian plane so that we can plot our function. So in this case, we have 1 2 3 4 5 6. No, 1 2 3 4 5 6. 1 2 3 4 5. Okay, I didn't do this properly. Just try and fix it. Okay, cool. 4 5 6. Remember, these are all negative, right? So okay, we have another one here. 1 2 3 4 5 6. So everything is negative here, right? Negative, 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 negative. So now let's plot our function. So what did we get for our thing? What did we get for our the y coordinate? Our y coordinate, the y coordinate for our turning point. So we had negative 1, we had 2 negative 1, we had plus 3. Okay, cool. So we got 2. Yeah, so here we got 2 for our, what is this? For the y coordinate of our turning point, right? So remember, this is our turning point. Okay. Okay, cool. So now let's plot our function. So when plotting your function, you can do several things. You can either start by plotting your turning point, or you can start by plotting all these coordinates. So the first coordinate is negative 3 and 6. So let's do it. So we have negative 3 for x, which is this one, right? And then we have 6 for y. So meaning our point is going to be here. Our coordinate is going to be somewhere here. Okay, let's use a different color. Yeah, cool. So let me just we can even do this. Yeah, so yeah, we can have here, and then our next coordinate is negative 2 and 3. So negative 2 is here, and then 3y is here. Okay, Then the turning point is negative for 1 for x and 2 for y. So here we're gonna have it here. Okay, so let's make our turning point to be let's say make it a purple. Okay, purple for you to see, yeah, and then go back to blue. And then okay, for our next point is 0 and 3. So we're gonna have 0 as our x and 3 as our y. So it's gonna be somewhere here. And then our last point is 1 and 6. So we're gonna have 1 as our x and 6 as our y. And then we're gonna have something like this. Okay, so now we have plotted all our points. So what is the next step? The most important step, the step that have all your marks connecting your function. So you're gonna just do it like this. You're gonna do it like this to show these arrows to show that it is continuous, right? So if you've done this, okay, let's do this. This is why. So okay, cool. Yeah, so after doing this, you've successfully plotted your quadratic function and you are ready to take your marks. That's how simple it is. So now let's move to the next.